Right now, while you sleep, something strange is happening behind your closed eyelids. Your eyes are moving, not slowly drifting, actually darting back and forth, side to side, as if watching something you can't quite catch. Your body is paralyzed, your conscious mind is gone, and yet your eyes are racing. The question is why, and the answer reaches all the way down into what it means to be conscious at all. For most of human history, nobody knew this was even happening. People slept, they dreamed, and in the morning, they remembered fragments of vivid, impossible worlds. But the actual mechanics of what the brain was doing during those hours, that was a complete mystery. Then, in 1953, a graduate student made one of the most unexpected discoveries in the history of science, almost by accident. Eugene Azarinsky was a PhD student at the University of Chicago, and he was exhausted and broke. He needed a research project, and his supervisor, Nathaniel Kleitman, handed him what seemed like a tedious task: watch sleeping infants and track their eye movements. Azarinsky set up crude electrodes near subjects' eyes, and what he saw on his recording equipment made him think the machine was broken. The readout showed wild electrical activity, the kind of frantic signal you'd expect from someone wide awake and alert. But the subject was deeply, undeniably asleep. He checked the equipment. He rechecked it. He woke the subject. The person said they had been dreaming vividly. He woke them again later during a quiet period. No dreams. Azarinsky had just discovered REM sleep, rapid eye movement, and nothing about the brain would ever look the same again. So what actually causes those eye movements? The short answer is your brainstem, the ancient reptilian core of your brain that handles breathing, heartbeat, and basic survival. During REM sleep, a cluster of neurons deep in the brainstem, called the pontine tegmentum, fires bursts of electrical signals upward through pathways that connect directly to the muscles controlling your eyes. These are called PGO waves, pontogeniculo-occipital waves, and they are essentially the brain's own activation pulses. Here's what makes PGO waves fascinating. They don't just move your eyes. They flood the entire visual cortex, the part of your brain that processes sight with activation. In other words, your brain is artificially generating vision from the inside. It is simulating the experience of seeing without any light entering your eyes at all. Your visual system isn't resting. And here's where it starts to get genuinely strange. Researchers have mapped the brain activity during REM sleep and compared it to brain activity when people are awake and looking at something. The patterns are remarkably similar. The visual cortex lights up. The emotional center, the amygdala, becomes highly active, often more active than during waking life. The prefrontal cortex, which handles logic and self-awareness, goes relatively quiet. You're seeing, you're feeling, but you're not thinking critically. Sound like dreaming? That's exactly what it is. But here's the question that split the scientific community for decades. Are the eye movements actually tracking something in the dream? Are you literally watching the dream play out, your eyes following the action the way they would in real life? This idea, called the scanning hypothesis, seems almost too poetic to be true, and the evidence is genuinely complicated. Some studies found tantalizing correlations. When dreamers reported looking up at something in their dream, their eyes had moved upward during REM. When they described scanning left and right, the eye recordings showed lateral movement. In one famous series of experiments, researchers used lucid dreamers, people who are aware they're dreaming and can follow instructions, to deliberately move their eyes in prearranged patterns as a signal to the outside world. Those lucid dreamers communicated from inside their dreams. They agreed beforehand. 3 left-right eye movements means, I am now dreaming. And while hooked to recording equipment, they signaled, and the researchers received the message. It remains one of the most eerie demonstrations in all of sleep science. But it still didn't fully answer the question, because the scanning hypothesis has a serious problem. People who are blind from birth, who have never once seen an image in their lives, also experience REM sleep. Their eyes also move, but their dreams contain no visual imagery. They dream in sound, in touch, in emotion. So the eye movements can't simply be tracking a visual scene, because for these people, there is no visual scene. the eye movements are happening for a different reason, or maybe for several reasons at once. Which brings us to the deeper theory, the one that most neuroscientists today find most compelling. It's not just about dreaming. REM sleep and the neural firing that drives those eye movements appears to be one of the primary mechanisms by which your brain consolidates memory. While you sleep, your brain is replaying experiences from the day, sorting emotional weight, strengthening important connections, and pruning ones it doesn't need. The eye movements may be a visible signature of this massive internal data processing. Matthew Walker, a neuroscientist at UC Berkeley, has described sleep as emotional first aid, a nightly process that strips the sharp emotional charge from difficult memories while preserving the factual content. And REM sleep is the specific stage where this happens most intensely. The amygdala and hippocampus, your emotional and memory centers, are in high communication during REM. The eye movements aren't random noise. They may be timestamps on your brain's filing system. Here's the mid-video twist that changes how you think about all of this. We've been asking, why do your eyes move during unconsciousness? But that framing contains a hidden assumption. You are not fully unconscious during REM sleep, not even close. Unconsciousness, true unconsciousness like general anesthesia, shows completely different brain patterns. Flat, slow, barely organized. REM sleep is almost the opposite. Your brain during REM is in measurable electrical terms, nearly as active as when you're awake. Anesthesiologists have known this for years. Put someone under general anesthesia, and their eyes don't move, or move only slowly and randomly with no organization. The brainstem's REM-generating machinery is suppressed, but in natural sleep that machinery is running at full power. The eyes move because the brain is actively choosing to run a simulation. You're not unconscious. You're in a different mode of consciousness entirely, one that we barely understand. Humans have been trying to make sense of this other state since before recorded history. Ancient Egyptians believed dreams were messages from the gods, received by a soul that partially left the body during sleep. The Greeks thought the dream state accessed a realm of truth unavailable to the waking mind. They weren't entirely wrong, just using the wrong vocabulary. What they were observing was the brain in a profoundly different mode of operation. Today we can watch this happen in real time. Using fMRI imaging during REM sleep, researchers can actually decode rough visual patterns from a dreamer's brain activity, essentially reading the outline of what someone is dreaming about. In Japan, researchers have done exactly this, using machine learning to match brain activation patterns during REM to categories of images. They can tell if you're dreaming about a face, or a building, or an animal. The dream is not private in the way we always assumed. And yet, the more we can measure, the deeper the mystery becomes, because here is something no one has plainly explained. During REM sleep, you are physically paralyzed. Your brainstem sends inhibitory signals to your motor neurons. Every voluntary muscle in your body is locked. This is protective, presumably, so you don't act out your dreams. But the eyes are exempt. The eye muscles are not paralyzed during REM. Why? One theory is functional. The eyes may need to remain mobile because they serve the brain's internal simulation, as we discussed. Another possibility is evolutionary. In early animals, keeping the eyes mobile during sleep may have allowed for rapid threat detection, even while resting. A third, stranger idea, the extraocular muscles, the ones moving your eyes, have a fundamentally different type of nerve fiber than your limb muscles. They may simply not respond to the brainstem's paralysis signal the same way. Animals tell us something important here. Every mammal studied shows REM sleep with eye movements. Dogs twitch, cats flicker, even platypuses, with some of the most extreme REM activity of any animal ever recorded, show rapid eye movements. Birds show modified REM, and some fish may show early precursors to it. This is not a quirk of human sleep. This is one of the oldest programs in the vertebrate brain. Whatever REM is doing, evolution decided it was worth keeping for hundreds of millions of years. In fact, the amount of REM sleep we get changes dramatically across a lifetime, in a way that reveals something crucial. Newborn babies spend nearly 50% of their total sleep time in REM. those eyelids are going wild. By adulthood, that drops to around 20 to 25%. Researchers believe that in early life, REM sleep is helping to wire the developing brain, stimulating neural pathways that don't yet have enough real-world experience to activate them. The infant brain is essentially building itself using internally generated signals. The eyes moving is the visible edge of that construction, which explains why sleep deprivation is genuinely dangerous in ways that go far beyond feeling tired. Specifically, REM deprivation, disrupted by alcohol, certain medications, sleep apnea, or simple chronic sleep loss, impairs emotional regulation, degrades memory consolidation, reduces the brain's ability to connect unrelated ideas creatively, and appears linked over time to increased risk of serious neurological conditions. The eye movements are a symptom of a system you absolutely cannot afford to lose. So here's the payoff. When you watch someone's eyes move behind their closed eyelids, you are watching one of the most complex and ancient processes in biology. You are watching a brain rebuild itself. You are watching memories being sorted, emotions being processed, neural connections being tested and strengthened. You are watching a simulation so vivid, the brain treats it as real. The eyes move because the brain is working, intensely, purposefully, in a mode of consciousness so different from waking life that we've spent all of human history trying to understand it. And we still don't have the complete picture. And maybe that's the most profound thing about all of this. Every single night, without your permission or your awareness, your brain enters a state so active, it nearly matches waking consciousness, generates its own light, its own motion, its own narratives, and does the invisible maintenance that keeps you emotionally stable, creatively capable, and fundamentally human. The eyes moving is just the one part you can see from the outside. The rest of it is happening in a place science is only beginning to map. Tonight, when you close your eyes, somewhere between 1 and 2 hours after you fall asleep, your brainstem will fire its ancient signals. Your eyes will begin to move, and you will enter that other country. The one your brain has been visiting every night since before you were born. We've learned so much about what happens there. But here's the question that nobody has fully answered yet. If your brain is running a vivid conscious experience every single night, one that feels completely real while you're in it, then what exactly is the difference between that and waking life?